Okay. Alhamdulillah, Professor Indra Mahlia now is with us today. And Prof, before we begin with your lecture, please allow me to read your short bio, ya, Prof?
Go ahead. Thank you, Dr. Melanie.
Thank you, Prof. Okay. So, Professor Tengku Merah Indra Mahlia is an Australian engineer and a highly cited researcher in the field of engineering. Currently, he is serving as a distinguished professor at the School of Civil and Environmental Engineering, University of Technology, Sydney, or UTS. He is a key core member of the university's prestigious Center for Water and Wastewater Technology. Professor Mahlia's research interests span a wide range of areas, including energy and fuels, techno-economic analysis, water and energy nexus, life cycle cost benefit analysis, and also circular economy. His dedication to advancing knowledge in these domains has secured over $5 million in funding for numerous projects supported by government and industrial organizations. Recognized for his exceptional scholarly achievements, Professor Mahlia has consistently been named a highly cited researcher in engineering by Clarivate Analytics from 2017 to 2022. Also, this year, yeah, Prof. Furthermore, the Australian, yep, Prof.
Hopefully,
yeah. they haven't
announced
released, yeah. Furthermore, the Australian acknowledged his leadership in sustainable energy, especially in engineering and computer science, in a special report published in 2019. Since assuming his role as a distinguished professor at UTS in 2018, Professor Mahlia has exhibited a keen interest in mentoring early career researchers. His guidance and support have been instrumental in fostering the success of his students and fellows. Notably, two of his former PhD students have been distinguished as also a highly cited researchers in engineering and cross-field. With his research accomplishments and dedication to nurturing the next generation of scholars, Professor Indra Mahlia continues to inspire and shape the field of engineering, leaving an indelible impact on sustainable energy and environmental engineering. Also, Professor Mahlia is a polyglot who is fluent in and can peer review in English, Indonesian, Malay, and Chinese. Okay. Thank you, Prof. How is the weather in Australia today?
That's why I wonder why you name it summer course. We are here winter actually.
Yeah, still in winter, yeah, Prof. Yeah, but
and you name it summer course.
Summer course in Northern Hemisphere, and in Indonesia always summer.
All right.
Yeah. Okay. Prof. Everybody. Okay, Prof. Maybe I just want to share you the profile of our participants, Prof. Yeah. This year, not like previous years, our summer course, we organized the summer course in hybrid mode, Prof.
Oh,
yeah. So last week we did the summer course is organized in Bogor for 2 days, and also they go field trip in our village, Desa Binaan, gitu, Prof. Desa Binaan of our department. And for 3 days, they also went field trip in Bali, Prof.
I see.
So that's why, because it's a hybrid mode, not hundreds of participants like previous years. Yeah, because they also have to pay for the summer course fee, and for Bali field trip, also in field trip in Bogor. Yes, and they come from totally 9 countries, including Pakistan. Hamza. Hello, Hamza. Say hi to Prof. Indra Mahlia. He is student from School of Medicine, Prof. So quite diverse, our participant from School of Medicine, and he's also a Hafiz Quran. Hamza from Pakistan. And also, Prof, we have 7 Malaysian students.
I see.
Yeah, from UPM.
Oh.
Dara.
Apa kabar?
Yeah. Prof. Indra Mahlia, previously, before coming to Australia, Professor Indra Mahlia also a professor in Malaysia University, ya, Prof, ya?
University of Malaya.
Yeah.
I got my master and PhD from University of Malaya, actually. Tak dengar apa dia?
Tan Sri Gaus Jasmond, Vice Chancellor University Malaya.
Dia yang bagi kenal. Dia yang bagi I professor dulu.
Oh, iya ke? Itu kenalan saya tu. Nanti saya sampaikan salam. Okay.
Yeah, small world, huh? Yeah, and also some participants from Ghana, Rwanda, and also Bangladesh and Australia. One, my daughter, Prof. Raisa.
Oh,
yeah. Okay. So that's so that's the our students range, Prof. Okay, Prof. Now time and place are yours. Thank you.
Thank you very much, Dr. Melanie. Assalamualaikum warahmatullahi wabarakatuh, and very good morning. Actually, these 2 parts of the presentation. The first part, I will try to talk about this slide things where actually the material taken from the software. Its name what we call this HomeAgreed. If we still have time later on, I will show how to run the program. This one is actually to show you how a very simple act that can change the resource of energy for university from what we call this fossil base to become renewable energy base. That's the thing. And this act is of course based on the global warming, which we can feel now, and especially in our place, Dr. Melanie, where almost every year we have this what we call this bushfire here because of global warming. And the impact of global warming, even the country like Indonesia, we can feel today, where the rise of sea level, such as in Jakarta, where they have to move the capital to Kalimantan because of the rise of the what we call water in the sea, and the earth natural resources also nearly reaching the point of no return. What I mean here, actually, the one that the resources in the world now already in the surface of the world, you don't need to extract anymore. What we need to do now to reprocess, which is the world change the economy of the world from linear economy to become circular economy, where in Australia itself, as you can see, we are changing to electric vehicles, but there in the future there is another problem from electric vehicle, especially related to batteries, where we have to reprocess the batteries to avoid this negative environmental impact. And one of the activities that mainly contributed to climate change is energy generation, where in many countries, including Australia and Indonesia, we are using a lot of fossil fuel, especially coal, which is well known have a negative environmental impacts. And for this, the solution is to use the renewable energy. Like in Australia, they encourage to use the renewable energy even in the household. For example, her house in Australia, she has the solar panel up there. Our house, 5 kilowatt solar panel, where sometimes this thing we generate solar panel for ourselves, where we can use for if we set, for example, for rice cooker or clothes dryer, we can do it in daytime instead of at night, where we use directly the renewable energy or electricity generated from renewable energy, where when there is excess renewable energy, we sell it to the grid. To Indonesia, they call it PLN. We sell it for the grid. Of course, they will buy with cheaper price rather than when we buy from them, the price more than double. But when we sell, it's quite cheap. But okay, it's at least we save the environment. So there are many types of renewable energy like solar, wind, hydro, and wave, and so on and so forth. But mostly now in the world, the most popular one is solar and wind. And the current trend, because of these renewable energy things, they use for microgrid. Microgrid means we generate electricity with small amount using source that in the area. Then we use the electricity in that particular place. But if there is excess electricity, we sell it to the grid, to the company that distribute the electricity. This unlike now in Indonesia, mostly we use bulk electricity system, legacy bulk electricity system, which is the electricity generated by a very big company in certain place and send it, distribute to our house through transmission system. But in the microgrid system, usually we develop small grid in every house, in every office, in wherever we can, in every company. We put the solar panel in the roof. If possible, we put the what we call wind turbine, and we generate electricity there. We use it or we save it. One of the way to save electricity. The problem with renewable energy right now is this, the storage. The storage the only commercial storage that widely used is battery. Some of the company try to store it as a hydrogen energy, but still it's not commercial yet because still very expensive. So what we have to do this one to decrease the price of the storage, like hydrogen energy, where when we use in the car, the excess is the only water and like not dangerous chemical. Unlike now, internal combustion engine, where we release CO2 and NOx and so on and so forth, where can have the negative environmental impact and health negative impact as well. So the future is in my opinion, is hydrogen, not battery. So because to process the battery is a bit difficult. So we generate electricity, we save it in hydrogen, and when we don't have the electricity or we don't have renewable energy, we can reuse this hydrogen thing to generate electricity that we need. So this in modern of microgrid include the multiple generation and storage resources. As I told you, no storage, still we use the battery. And the other thing, one that developed in Indonesia, in Australia right now, we try to pump water in large amount. When we have solar and wind, we pump water in high amount and we keep it, and we use that water to generate electricity at night. That's one of the way. And microgrid can also be connected to a larger grid or operate independently without the need of the main grid. So this is mean you can use, for example, in Australia, there are many small towns in outback area in the middle that can develop their own energy system using solar energy, where for that particular town or for that particular village. So that's the use of the microgrid. And the main reason for microgrid includes improved resiliency, economy, clean energy mandate, grid firming, and peak demand reduction. Because in electricity, the problem now, they have to produce electricity at peak demand. They cannot be, because if they produce lower than demand, it will be, they have to rotate or ratio the electricity. Like in my hometown, sometimes they have to switch off some part of the city, and there are some other part of the city with electricity. That's because of the what we call the electricity produced is not at the peak demand, usually about double. So even though you produce double, sometimes you cannot sell all. Okay, and then sorry, a microgrid range in size is from 2 to 3 kilowatt to over 100 megawatt. Where the one that we have, Dr. Melanie, in our house is actually 5 kilowatt. So that we call the microgrid. So we already have at our house, and up to 100 megawatt. That's small. The comprise of any combination of the following technologies. Usually they have wind, there's renewable energy, generation, solar, generator. So they need controller, storage, electric load. For electric load like the one that we use at home, that the load for refrigerator, for air conditioning, and so on and so forth. And when we have excess electricity, we sell it to the grid. In Indonesia, we sell to PLN. In Malaysia, we sell to TNB. So from the grid, the one who distribute electricity for the whole country, for the whole society. And this one is actually very suitable for Indonesia, because we are in Indonesia. We have Indonesia is a island country located in Southeast Asia, lying between the Indian Ocean and Pacific Ocean, and its length is 5,100 kilometers. For foreigner, maybe if you can, this one is actually the length between Tehran to London. It's very big country. So it's very difficult to distribute electricity except if we use microgrid. So from the west to the east, about 1,800 kilometers, and it has around 18,000 islands in Indonesia. So that's why very suitable to use microgrid other than bulk grid. There are still numbers, a lot of islands without a stable electricity supply in Indonesia. It's one of my paper calculate the electricity consumption for the Island, which is facing the Indian Ocean. These are the proportion of a total energy, electricity, renewable energy mix in Indonesia. As you can see here, Indonesia only use about 9% of the renewable energy. This one from the total energy, including from oil, coal, and so on and so on. From renewable energy, only 9%. For electricity, because energy is so many things. There is fuel for internal combustion engine, fuel for ship, and so on and so forth. So they want the total energy, many types of energy. For electricity itself, we use quite high, about 12% of renewable energy for electricity in Indonesia. Okay, mostly generated using coal. There are places with abundant coals in Indonesia, many places, especially in Kalimantan. And for renewable energy mix, still mostly use biomass, mostly from palm oil, because Indonesia now the biggest palm oil industry in the world. The second one, I think Malaysia, and the second one, the biggest one is geothermal, and second one biomass. And we still have a small amount of wind and solar, unlike in other countries, mostly they use solar. So what is the objective of this particular study? This study is actually the purpose to encourage the use of renewable energy in the country as a replacement for coal, fossil fuel, gas, and oil. So we can replace this thing with renewable energy, especially for electricity generation, to conduct a techno-economic analysis and optimization of campus grid-connected solar PV wind turbine using HomerGrid, one of the software that provided by one company, which the data collected by from NASA, so easy to identify the longitude and latitude of the point at the surface of the Earth. And the third one is to create a critical mass, which the future generation like you can learn and contribute to the society. Using this HomerGrid, there are some methods that we have to follow. For the first, let's talk about this HomerGrid first. This HomerGrid was developed in 2018, actually, it's very new. More efficient way for modeling hybrid energy system and analyzing the solution for lowering the electricity cost for a grid-connected system. What is grid-connected system? This grid-connected system, there is a standalone renewable energy where they generate energy they use for themselves, they don't sell it. And when they don't, they have, usually they use battery to save energy, and they use it at night, or when the energy, when the renewable energy unavailable. Where grid connected, different. The grid connected, the system is connected to main grid. To main grid, where when we have electricity, we use electricity for ourselves, but when we have excess electricity, we sell it to the grid. That's what, and this software is used for that. There are another software, the elder sister, called Homer Pro, where this one usually used for independent, standalone power plant, standalone renewable energy. where in the certain island, small island, you want to develop renewable energy, we use Homa Pro. So this Homa Grid you can use in your campus as well, Dr. Melanie, in the IPB University. So you can calculate you can generate electricity based on the space available in the campus. And it is a very powerful tool that integrates engineering and economic data. We are engineers sometimes. We say this one very good, very efficient, but we don't calculate the economic thing. But the one who make decision, even in Indonesia, mostly economists. If the thing, that's why we are still using the what we call coal, because the one who make decision is economists. You, Dr. Melanie. For me, I just can purpose the thing, but the one who make decision is always economist. So engineer, we have to come with the economic data to prove this one is useful, can be implemented in certain place, in certain country. But from my opinion, the problem in Indonesia, because we have abundance of coal, so the price of electricity quite low. Unlike in Australia, very expensive. So when the price of electricity quite low, the price of solar panel is still high. That's the thing that we have to play around. We have to calculate like sensitivity analysis and so on and so forth. And for user may analyze several components and design output, find the cost competitive point for alternative technology, to examine the strategies for reducing the project risk and identify the best cost-effective design. For this case, sometimes, for example, in Indonesia, sometimes the problem is the company itself. Because if we generate electricity ourselves and we sell to them, the profit for the company become lesser. So they don't want. That's why they don't want the society to generate electricity themselves because of it. But for long term, of course, everyone will get benefit if they use renewable energy. So that's another problem. Unlike here in Australia, the company who generate electricity or the state government willing to subsidize the residential, the household to install the solar panel. Like at my house and the Melanie house, we install for free, installation free, but still we have to pay I think about 50% of the solar panel price. And the software replicates real world performance to help the system designer and optimizer make a better decision for the future. That's Homa Grid. About Homa Grid, there is as I told you, two things: Homa Grid and Homa Pro. Homa Grid is a new one created for grid connected. Then how it works? For this one, for this software, the first thing you have to have is the load profile. Load profile means the electricity profile, how much you use per day, like 24 hours. So you average this thing for 1 year, then we can calculate the whole thing. Then site specific resources, what the source that you have over there. In some areas, good to use hydropower. In some areas, like in Velkra, like in PTP in Indonesia, palm oil mill industry, we use biomass. Depend on the area. So for this thing, you have to know latitude and longitude of that particular place. So based on that, you see what you can use the resource available over there. That's the good thing of this software, which is unavailable in other software. Like you have to calculate yourself about the resources, and you can see this one sometime from Google Earth. If you have latest Google Earth, you can see there is a river there, whatever available. So you design for your own future, for your own country. And then system component. Okay, system component mean there are many types of renewable energy. So we have solar panel, we have wind turbine, hydropower, and so on and so forth. So the component you propose to the system. Okay, then the system, this homogrid will calculate sensitivity analysis. Sensitivity analysis means when you change the price of fuel, because you have to calculate usually for 25 years, 30 years. So you have to increase the price of fuel. Now, like in Australia, keep changing and keep increasing. When I moved here 5 years ago, the price of the fuel only $1, now close to $2. So you have to calculate that sensitivity things about the fuel, and then the system will optimize the software will optimize the system which equipment to be used, and then we calculate the simulation result, including the engineering and economy. How many turbine, how many solar panel that we need for that particular place, and then performance, how much the renewable energy fraction, how much we have to invest, how much the NPC, net present cost, and so on and so forth. And there are various reports that you can generate depend on what institution you want to submit. So every institution, they want, like an engineer, they want to know how much the efficiency, how much the renewable energy fraction. But for economists, they want to know how much money they have to invest, how much they will get. So this the software can provide this thing. Just you play with sensitivity analysis. What required for this software? This one is actually the more detail of the one that I repeat. Location specification, like longitude and latitude. The data required for modeling is the average electricity load, how much electricity consumption per year, for example, for your university, Dr. Melanie, or much. And this one can be generated, can be created by the electricity bill. we can calculate from electricity bill, and the daily radiation in that particular in that particular area. For example, in your hometown, Bogor, always rainy. It's not really suitable for solar panel. It's always rainy. So we can check and we can calculate using this software. Later on, they don't. If it's not suitable, then they don't recommend that particular renewable energy system. Then daily radiation and clearness index. This one required for solar panel. Daily temperature at the location, which is required in the solar panel. And system architecture. Based on the available data, then we'll propose the system architecture, which is how many, for example, we propose this wind turbine, solar panel, boiler, biomass boiler, and so on and so forth. You can propose. Its later will be optimized by the system. This is what we have to do actually. First is start, we specify the location, then we find how much the energy load and utility grid, including tariff, because we need to calculate if the tariff so low, sometimes it's not beneficial to implement renewable energy. That's why we have to define the tariff. Then system architecture, we propose the architecture of the system, then we get the solar, wind, and temperature data from that particular place, and we calculate we input the techno-economic data, like actually this we input the economic data like interest rate, like discount rate, and so on and so forth. in this area. Then we calculate the result. If we satisfy with the result, like cost of energy, renewable energy fraction, net present cost, then we propose the system. But if we don't satisfy with the system, we change the things in the system architecture. We change the system. For example, for this one, for my calculation, the place that I calculate is here. It's at my hometown, my former university. It's called Siakwala University. And the university, when we zoom this thing, it become like this. The university is over here. Over here. In terms of land, one of the biggest electricity university in Sumatra, maybe. We have a lot of land still there in Aceh, Indonesia, and about 200 meters from here, from university, that there is a river here. It's actually a man-made river. It's quite from here to here about 300 meters. So we use this wasteland to put the things here, the renewable energy system, one turbine and one the solar panel. This one after calculation actually. So we have to calculate first, and the place is here, and the university is here, and this like a field that we can put the renewable energy system. And then we need to define load. To define load, they don't have load there. They don't measure the load. So I calculate the load from the electricity bill provided by university here. This one is actually January, February, March. This is month. The lowest in the, where is it? January, February, April, the lowest, and the highest around here. What is this? September, October. So this electricity per day. Then based on this, I calculate the load, which is presented here. Unlike in Australia, we have 4 seasons, so the load in tropical country almost similar. It's not changed so much. It's almost similar. So we calculate average load like this. There's this actually at night, and the morning the student will come. At 9, it's a full load already until 5 o'clock. Student going back home, and at night only the electricity required for lamp outside of the building. So that's why electricity load is lower. And based on that, we take the data at that particular place, the one that in this place. So I collect the data for this particular place. All right. From where? From this data provided by software. It's actually collected from NASA and Lawrence laboratory, some laboratories at the US, for all over the world. So for that particular place, the solar radiation is like this. Yeah. And this one, the clearness index. So the data is provided by the software. They always update the software, the data, and the monthly average temperature like this. Of course, the highest temperature in May in Banda Aceh, and the lowest temperature is in October, always rainy. And because here I propose the wind speed, the wind turbine, so we need to know the wind speed. The wind speed in that particular place is in January about 6, the highest in August, I think this one, close to 6.5, and the lowest in April. And this one you can see later affected in the electricity generation. So for that, for this month, we have to use the highest electricity from the grid. We have to buy from PLN. Okay, when we generate more than enough, for example, here we sell to grid. Okay, based on that data, therefore, I propose the system. There are system here. So we have this one is actually electricity from grid. This is the load that I show you just now, and I propose PV. PV is the DC, so we have to have converter, the DC to AC converter, and I propose lithium battery, and we have this. I propose one turbine, 100 kilowatt, and this is PV. The price, okay, the operating cost only, maintenance cost only $10, all in US dollar, and the lifetime is 25 years. And I propose the storage using the battery for 10 years, wind turbine, 100 kilowatt, 25 years, the lifetime, converter, DC AC converter, and simple tariff, utilities. We pay about 800 rupiahs per 800 to 900 rupiah per kilowatt hour. So it's equal to 0.06 USD per kilowatt hour. You can change this thing in rupiah as well, because this one I published in the journal, so we have to change the monetary thing to USD, so easy for them to understand. And then the solar cost here, solar cost is different, because when we purchase solar, only one piece of solar panel is actually more expensive than we purchase in bulk number. It's when we purchase, for example, for this, the price of solar will be much cheaper. All right, the capacity price of generic of this lithium battery is similar. When they purchase in higher number, it's become cheaper, or 50% cheaper. And the economic analysis we calculate here that, of course, we have to input interest rate, levelized energy cost, the cost of energy when we generate using the renewable energy, net present cost, the overall cost of the system, salvage value, the end cost of the system, internal return rate. This one, the thing that they want to know by especially by economists. Return on investment. Dr. Melanie want to know this thing. Simple payback, balik modal, in call is in Indonesia. When is it? That's what then total annualized cost that we have to give to. Then currency we use here. With $1 equal to 14,000 rupiah, nominal discount rate 6.6, expected inflation rate 2%, and project lifetime 25%, 25 years. This is the calculation. It's actually Indonesia cheaper overall cost, net present cost, as you can see here, cheaper to use electricity from the grid. Yeah, but if we use electricity from the renewable energy, we pay cheaper, the cheapest. Okay, this one, and operating cost, we get the money per year, about 500. We don't have to pay, and we put in our pocket. And here we use up to 82% of renewable energy fraction. Most energy coming from renewable energy. And we can also sell the electricity to the grid. Okay, as you can see here, there are 3 systems now. Why there is no battery? Because at early stage, we propose battery here. And when we run the system, when we run the software, battery drop from the system because it's not optimized means if you use the battery, it's cheaper to buy electricity from the grid rather than using the battery. That's the reason. That's why the battery dropped here. So now the system exactly similar, but without the battery, because we want to buy, if we don't have electricity, we just purchase from the grid. So the detail optimized system, the size of the panel is about this 682 kilowatt, and one unit turbine, wind turbine, and this one price from utilities, and 431 unit converter. And the electricity production, as you can see here, 800 kilowatt hour per year. We use electricity from solar panel actually, and 371 from wind turbine. We just purchase electricity from utility about this amount, maybe around how many percent? 15 or 20% by using this thing. And this you can see when we use it. As you can see here, this is the only time we use the electricity from the grid, from the power generation. Yes. The rest, this one, we use from renewable energy sources. This one from wind, this one from solar panel. So we use this one. This one is actually only at night, where the grid is very low. That's why around how many percent? Around 10 to 20% or 25%. Mostly we use from renewable energy sources. Then when we use it, this one, because this one, as you see in April, there is wind in April low. That's why we don't generate. And this one, again, in maybe sometime in September or October, where wind speed is low. This is the cost of the component. Mostly the cost is capital cost, because we have to buy turbine at early stage, operating cost very low, and this one there, and life cost. This is a cash flow for 25 years. So we need money at early stage. This is internal return rate, return on investment about 2.41% per year. And a simple payback period quite long, 17 years, which is usually economists are not interested. And we make money about $8,000 per year by selling electricity to the grid. This the comparison between the using electricity from the grid and by the renewable energy. So CAPEX will become zero, and we save money. Actually, we get money this yearly. And CO2 emission, it's about 1/3, because we still use about 10 to 25% of electricity from the grid. Okay, conclusion. The study found that it is possible to implement the renewable energy system generated by solar PV and wind turbine system in public higher education in a low electricity rate countries such as Indonesia, because our electricity price is quite among the lowest in the world. That's the problem. And the price of renewable energies like PV and turbine still quite expensive. The study found that it is possible for a public institution connected to utility with great percentage of renewable energy production up to 82%. For this case, we use 82% of electricity from renewable energy Proposing many renewable energy devices sometimes will only increase the cost when electricity price is low. As for the energy storage device in this proposed system, as you can see, the battery is dropped from the system because it's expensive compared to if we buy electricity from the grid. Okay. The main obstacle of implementing renewable energy in Indonesia is low electricity costs, primarily generated using a cheap coal that is abundant in the country. Finally, because of limitation of the software, the exchange rate, nominal discount rate, and expected inflation rate were assumed to be constant in this study. This one, the software only we can put one price of electricity. We cannot change because price of electricity in Indonesia keep increasing as well. So this one you can actually in the future try to calculate when the price of electricity increase, changing, or you can put this one as a percentage changing per year, but you have to know the history of the electricity price. And it is suggested that in the future research other type of software that can be programmed for this type of calculations should be used for you, youngster. So at the end of our presentation, I always like to mention about these two scientists' wisdom. The first one, imagination is more important than knowledge. And the second one, which is, I like it so much, it is not the biggest, not the strongest, but the one who most responsive to change that will survive. Do it. Change. Thank you very much.
Thank you, Prof. Indra. That was so inspiring. But I hope this system can be applied in IPB. Although our Bogor is quite
always
gloomy and rainy city. not so tempting for a solar system. Anyway, all right. Thank you, Prof. Indra. Okay, participants, okay, students, now it's your turn to raise question or anything to Prof. Indra, or maybe inputs, or maybe you can also say something about how this renewable energy to provide electricity in your country applied. Maybe you want to share. Okay. Anybody? Daisy, how are you today? Hello, Daisy. Daisy
Hello,
is from
Hello,
Daisy is from
everyone.
Ghana, Prof. Mahlia.
Oh,
Daisy,
hi, Daisy.
Hello, Prof. Thank you for the lecture. Prof, I actually have a question.
Yeah, go ahead.
Okay. In the closing remarks, Ibu made a comment that for a city like Bogor or which is always raining, what, from your own perspective, what would be the best option?
For rainy, like the best option to use the small wind turbine.
Oh, okay.
Because good thing of wind turbine, unlike the solar panel, if the wind speed is not enough, you can increase the hub, make it taller.
Okay.
That's the thing, make it taller. Here, for example, in Australia, they put this thing between the Departemen house. They put in the at the top of the hill, the solar panel, and what we call the hub is very high there. So we can, because the highest the elevation, the faster the wind speed, the faster the wind speed. Yeah, that's one of the way.
Okay. Thank you very much, Prof.
No worries.
Okay, wind turbine, yeah. For raining city like Bogor. The Prof. Mahlia
one of the way.
proposed. Yeah, one of
of the
the
way. Usually rainy city
alternative.
they have a good source of the water as well. You can use water turbine.
Yeah. That's interesting. Okay, other question. I also want to say hi to also from Pakistan, Fahim. Fahim, are you here? Fahim? Fahim said hello this morning also. Fahim? What? Oh, okay, I don't know. See, he's not here anymore. How about Tasnim? You have any question to Prof. Mahlia?
Not yet. Thank you.
Okay, not yet. How about Munifa? Munifa?
Yes, doctor.
Yeah.
No question.
Dara
Dara.
question.
Dara.
Okay.
Yeah.
Before that, I want to send the message from Tan Sri to Prof. Tan Sri say that nampak macam dah put on weight to the professor lah. Tan Sri kirim salam. Tan Sri kirim salam pada profesor. Lepas tu dia kata profesor ni antara top akademik di UM. Sangat hebat orangnya. Dia kirim salam ya.
Terima kasih.
Okay.
Waalaikumsalam warahmatullahi.
Okay, my question
Not only
is,
in UM, Dara, in the world. We are so proud of him. One of the most cited researcher in the world.
insyaAllah. Okay, Prof. My question is, did you think that the system can be used at the rural areas such as Sabah and Sarawak with some of the village, located in the deep tropical forest or mountainous area?
Of course, but for that area, better to use the Homer Pro. And one professor from UM already calculated for this pulau two islands, Sepanggi, something like that. I forgot he already calculated the potential of electricity generation from that particular area. That's the purpose of the software developed actually for that kind of area. Just they changed to this thing recently, this what we call Homer grid, which is connected to the system. Just they create this software just 5 years ago, originated, calculated for that particular area. Yes, but you use another software called Homer Pro.
Okay, Doctor. Thank you.
That's my answer. No worries.
All right. Thank you, Dara. Everybody, can you do on cam? Yeah, because Prof, because it's not too early. Now it's already 9 a.m. but they're still too lazy to be on cam, especially Mursid Thanos. Hello, Mursid. Now, did you comb your hair? Mursid also from UPM.
I see.
Hello.
Yeah.
Hi.
Yeah, I think. Yes. Actually, I do have one question. Why did you think, especially in Malaysia, why did you think the renewable energy, especially solar system, as you know, in Malaysia, they always sun. The situation. Why the government don't implement it in bigger scale for solar system? Because that's what I want to know, because Malaysia always get the sun, right? Why the government don't want to implement it in a bigger scale? Do you get it? Yeah.
Right.
That's my question.
Sometimes.
Thank you, Mursid.
Thank you for your question. This sometimes related, as I told you earlier, it's the company that generated electricity in that particular country and the government. You must have this the same policy where the government subsidize and the one have the household can generate electricity and the company willing to buy, like here in Australia. So if you ask me why, they don't see the benefit for the company and for government to do so. You know what I mean? The company will not get, of course, they have to share profit with you when you generate electricity, and the government has no benefit. And when the government-linked company who generate electricity, who pay tax to government or generate income to government, will reduce the profit from the electricity generation. That the reason they don't see the one who make decision like economists like Dr. Melanie cannot see the benefit of this thing. Because in Australia, we calculate the benefit for environment, where in Malaysia, maybe not yet. Like Indonesia, they don't calculate that thing. So in Australia, they calculate the benefit for environment higher than other country. Like, for example, I have to change my field of research here from biofuel to this kind of thing, because if you touch anything related to environment here in Australia, you will not get very difficult to get grant from government, because still this biofuel, they think that will have the negative environmental impact to environment, which is I agree with the government. That's what in some of the countries, when we produce this biofuel from palm oil, for example, we cannot sell in developed country. That's my answer.
Yeah, that's right.
So
Especially as already you said, yeah, Prof, in our country, in Indonesia, dirty energy is still abundant and cheap. Yeah.
The second,
Yeah.
the second richest man in the country is actually the one who did business in coal business.
Right. Yeah, that's
in
true.
Indonesia.
Right. Okay. Mursid, are you
yeah.
really satisfied with it? Okay. Right. Yeah.
So basically, as long they don't see the benefit of it, so they're not going to do it.
Right. Yeah.
Everybody.
Yeah, I understand that.
Everybody, including
Yeah.
here. They can see benefit of toward the environment. That's why they do it.
Right. Right. Not yet. Hopefully,
Okay, thank
in
you.
the future. Okay. Maybe I can give just one more question from you. Maybe after this, Professor want to share about the software.
Oh,
If
okay.
I'm not wrong. Oh, right. Yeah. One more question, Prof. Yeah.
Okay.
Any more question from you guys? How about Rezekinta Sembiring from Medan? Rezekinta, are you here? Kinta? No, okay. How about student from IPB? IPB students? Anybody wants to raise question to Professor? Maybe Andita? Andita, have you rolled your hair today?
I haven't.
Oh my goodness. So that's why you don't want to be on cam?
Yeah, not yet.
Okay. Andita is always make our time in Bali colorful, Prof.
Oh, I
Yeah,
see.
because yeah, she busy with her hair every morning. Get up from house in our hotel in Bali with rolled hair, but still beautiful. She's a beautiful girl.
Thank you. You too, Miss.
All right, maybe I don't think more question from the participants, Prof. Maybe Prof wants to share with us the software to
Okay, can you see?
Yeah, for this
Can
systems.
you
Yeah.
see the map now?
Yep. We can see.
This is the software actually, so you can like you can move this thing everywhere you want when you calculate for Sabah Sarawak, for example, and you get the resources. Yeah, the data from NASA prediction data 20 based on the data 22 years period. So data from renewable National Renewable Laboratory, wind speed from NASA. So this is a good thing of this software, where other software they don't have this kind of thing. So to calculate renewable energy, for example, we take this data, we just download the data. That's all we need to do. It's already there. It's already downloaded successfully. That's how this is the purpose of the system that we propose. So this one will be dropped for the system. And this the component PV, storage, converter, generator. You can use generator as well, and wind turbine, and we can calculate for electric vehicle charging as well. Yeah. This one for electric vehicle, and this one the project calculation, economic data like nominal discount rate, expected inflation, project time, lifetime, and so on and so forth. So you can use this thing. You can change to, for example, Indonesian rupiah. Indonesian rupiah, for example, you can change the tariff, but you have to change everything. Setting, and you can calculate for multi-year. That's you can change the price of electricity here. That's the thing, the component, the program, and if, for example, for the area that we have the what we call biomass, and we want to use the boiler, we can calculate as well. And we can calculate the thermal load, like in Australia, we need hot water, so we can calculate this thing. This is a good thing of the software. This is the load, and this is the utility. Utility means the system connected to main grid. So you have to put the price here. So you can see it change to rupiah now. I think that's all from the software.
All right. Okay, that's interesting.
Very simple.
Yeah, it's simple and yeah, I hope maybe IPB want to do calculation with this and see how's the output. Yeah, from this prediction from this software. Okay, I think that's it. Yeah, from this very inspiring lecture from Professor Mahlia today, maybe I just want to highlight that collaboration between economists and the engineer. We need the collaboration between economists and engineers like Professor Mahlia to push the application of renewable energy to provide electricity, and mainly especially in developing country like Indonesia and Malaysia, yeah. And of course environmental economists like me maybe can be more to bridge, yeah, this collaboration rather than pure economists, because
Yeah.
we also knows about this environmental thingy. Yeah. All right. Thank you so much, Prof. Mahlia, for your time today. Please don't be hesitate to again join our summer course in next year.
My pleasure, Bu Haji. My pleasure.
Yes. Thank you. And maybe
Okay.
next year we want to invite Prof. Mahlia also to join our field trip, yeah, in Bali. Maybe next year we will do a different itinerary, guys. I already see how if we do the field trip in Nusa Lembongan. I'm sure Prof Mahlia never been there in Bali, Pulau Nusa Lembongan, yeah.
Right. Okay.
Cool.
Okay.
All right. Again, thank you so much,
Bye-bye.
Prof. Please give applause for Professor Mahlia, everybody. Thank you so much. And please send my best regard for Ibu